Thank you, everybody, and welcome. Welcome to class. Welcome to our Python class, lesson 5 of our data manipulation with pandas in Python. This is the 18th topic of our training, and we've covered a whole lot. Tonight, we want to continue with pandas, and we want to learn some interesting aspects of pandas that will help us upgrade our knowledge in pandas and Python and will really be beneficial to our careers in data, in cloud, in DevOps, in software engineering, and in every tech career that we have. Today, if you are looking for a serious tech job, Python is required. Python is required. And so you need to really master Python. And so let's keep pushing. Let's keep pushing. I know we are learning, we've done a lot, but let's keep learning, let's keep learning, let's keep pushing, let's keep advancing and make sure that the knowledge we are acquiring are staying with us. The act of taking the first step is what separates us from losers. And I say us because we are winners. At Rita Africa, we are winners. All of you are winners. And this is what separates us from losers because we take the first step. Every wise person knows that you have to keep learning and you have to continue learning. You need to take the first step so that you will get ahead. And when it comes to mastering Python, when it comes to mastering our tech skills and our tech careers, we need to take the first step in learning. And this is what will help us get ahead. Don't be bored of learning. Don't be tired of learning. Let's keep learning. And every wise person, again, knows the importance of learning. What we are doing here is the solution to Africa. This is the solution to the problems we are facing. And this will help us transform the continent. So let's keep learning. Let's understand what we are learning and let's apply them in real life. Very soon, we'll move to the mastery phase and we are going to be applying all that we've learned into the industry in the real world environment. And we are going to do a whole lot with it. So let's keep learning and let's advance our skills. This is part 5 of data manipulation with pandas, working with data frames and working with series. Yes, working with data frames and working with series. And this lesson will help you to be able to efficiently load data, filter, explore, clean, and analyze data sets using pandas and gaining hands-on experience with data frames to enhance your data handling skills. Yes, so I'm so happy when we talk like this and we understand what we are talking about. It shows where we are going. It shows the progress we've made in our studies. It shows that we are making progress, we are advancing. Yes, when you hear people talking about neural networks and transformers, and they are talking about deep technologies and they really understand what they are talking about, you can see how amazing it is. And we want to advance, we want to make progress, we want to move from being beginners to being professionals. And so, with what we are talking about here, we understand them because we've done the basics, we've done the basics of Python, we've gone through all the basics, we've done what data frames are, what series are, and we are talking about data manipulation. So we understand what it means when you load data, when you filter, when you explore, when you clean data, and when you analyze data sets using data frames. And tonight we are going to move into another area that will help us understand our journey with pandas. Pandas is a powerful library in Python and is primarily used for data manipulation. Now, data is used everywhere. Data is used in cloud. Data is used in cybersecurity. Data is used in software engineering, and of course, in the data professions, in data science and data analytics, data is used. So Pandas is a very important library that we use to manipulate, analyze, and clean data. Pandas supports various data formats like Excel, CSV, JSON, SQL, HTML, and so much more. Pandas also works smoothly with other libraries such as NumPy, Matplotlib, and tonight we'll see how Pandas easily works with Matplotlib. Even when you don't import Matplotlib, you can still use Matplotlib within Pandas. It works with Seaborn, Scikit-learn, and Jupyter Notebooks for making data science workflows and all data workflows very, very efficient. We've seen that Pandas organizes data into series and data frames. And we've seen that series are one-dimensional labeled array. And of course, data frames are two-dimensional labeled tables. And last week, we took a lesson on series to understand how to create series from scratch. And this is very, very important because it's not every time that you import data. Sometimes you need to know how to create the data from code. So we understood what is meant by one-dimensional labeled array, and we understood that series can hold data of all types, integers, floats, strings, and other data types. A series is referred to as a labeled array simply because each item in the series has a row label. Each item has a row label. Each item has a row label. And this is really, really important. That is why we call it labeled array, because a series is usually an array. It is just an array. And we call it labeled array because each item in the array is labeled. And the label is also referred to as the index or the row label. So each item, you can see clearly that we have labels right here. So this is the label here for the first item. Over here, we have the label. We have the label here for the second item. Over here, you see the label for the third item and so forth. So this is why we call it labeled array, because series is an array. All right. Now, the labels helps you to identify the data, and it also helps you to access the data. So with this particular label, we can write code to access this data right here, because we can use this label as an index to access this particular data directly. All right. So we saw some examples of series from last week. And you can see that if you want to create series, you can just use the function .series, which is also a constructor. Later, when we are talking about classes, we'll talk more about constructors. So once you say .series, you can actually create a series like this, and you can just create out of a list. So this is an example of series. And this is very, very important for you to understand how to just call your PD and say .series to create a series. This is very, very interesting. And since we are talking about pandas, of course, you need to import pandas as PD. Yes, yesterday I saw someone who imported pandas as her name, and it was so interesting. The person imported pandas as her name. Yes, this tells you that the PD here is called an alias, and it is not compulsory that you call this PD. You can call it Zeph. You can call it Fred. You can call it Newman. You can call it NM. You can call it anything you want because it is just an alias. Just that in the Python community and in the data community, everyone uses PD. So for very serious works, you have to stick to PD. And anytime you want to refer to pandas, you can just go ahead and say PD. So within pandas, we have a function called series. If you say pd.series, you'll be able to use this particular function which is actually a constructor to create a series by inputting a list right here. We saw that we can have a series of strings. So the previous one, we saw that there were a series of numbers or integers. You can create a series of strings. You can also create a series of booleans in Python. And you can also create a series with custom labels or custom index. This means instead of using the default numerical indexes, you can actually input your own index. And this is so wonderful. Yeah, this is so wonderful. So with this, what is going to happen is that you are going to have a table that is going to output, the table is going to output math 85, English 90, and science 78. And this is actually going to behave like a key value pair situation. And so if you want to access maths, you can just call the index of maths or math, and it will give you 85. So even though this is series, it's going to appear like a key value pair situation. And as a matter of fact, when you look at series, series is actually a key value pair situation. So even though we refer to series sometimes as an array, which is an array, or more specifically, a list, because we were saying that in Python we have lists, and if you want to use lists for analysis, you have to rather use series. All right, convert a list to series. And if you have a list like this, you can actually make it series by just handing it over to series. But what is actually happening is that the series is a key value pair structure because the series actually has a key here and a value here, and the key maps to the value. Of course, in lists, we also have index numbers in lists, but this is more of a key value pair situation or structure, a little bit different from how a list also has its own index. All right. When it comes to series, series are, we refer more to the labels. The labels are really part of the structure. So they are labeled arrays. The labels are part of the structure. So they move together like key value pairs. And so in Python, we have a data structure that is key value pairs. And I don't know who remembers what data structure is made of key value pairs. All right, so someone says it is. Let me see the first person who will tell us the key value pair data structure we have. It is dictionary. Yeah. So when we think of series, series is more like key value pair situations. And this is why we can actually manipulate the keys. And the keys, we can actually use custom keys or custom labels to design the keys. All right. So over here, we created series from a list. We created series from a list stored in a variable. And we also created series from a dictionary. We created series from a dictionary. I wonder the output of this particular series. How was the output of this particular series? Who remembers the output of this series? Was it a key value pair situation? Did we have the apples as the keys and we had the numbers as the values? Is that what we had from last week? Okay, Roughly says yes. So you can see that series actually is more like a key value pair situation, and it aligns more with dictionaries, the dictionary data structure. But then if you create a series from a list, it will automatically assign numerical keys starting from 0. All right. And I'm just drawing your attention to the fact that the series really requires 8 labels. And so when we are talking about the structure of the series, we don't talk about it without the labels. The labels are kind of part of the structure. This is why it is more like a key value per situation. All right. So this is the same thing we created from custom labels as well. We also perform some basic operations, and you can see that just like a dictionary, you can call the series variable and call the key or the label, and you'll be able to access the value or the data. That same way, you can also access this by position. By position. So when you enter a number, it is going to access the data by the index position. All right, by the index position. So you can access it by the label or by the index position. And we'll talk more about this in today's main lesson. Also, we can do slicing in series. That is so interesting. We can do slicing. And we tried this last week. And we can also perform some arithmetic operations. You can actually take a whole series and perform mathematical operations with it and choose to store it wherever you wish to store it, either in a new variable or even in the same series. And we were also able to perform some descriptive statistics. And moving forward, especially the data students, let's now get ready for the world of statistics because we are going to be doing and reading a lot of statistics. We are going to be doing and reading a lot of statistics moving forward. So let's get ready because we've gotten there, especially the specialization students. Let's get ready because we are advancing into more statistics and other areas that will make training as data professionals complete. We can't be data scientists without statistics. We can't be data analysts without statistics at all. You can't even do machine learning without statistics. So let's tune ourselves to statistical techniques and statistical terminologies. So here we are going to see what is called mean. And mean is something that we talk about most of the time, and it simply refers to the average. And everyone here knows how to calculate the mean. Who can tell me how to calculate the mean? Who can tell me how to calculate the mean? Just in the chat, everybody knows it. I know. This is this is this is even below high school math. All right. I'm not talking about a function. I'm just talking about mean calculation mathematically. In mathematics, how do you calculate the mean? The mean refers to the average. How do you calculate it? Everybody knows it. All right, so the sum divided by the number, okay? Thank you, Nkuleko. Everybody knows it. Now, to the data students, the time is coming when you hear mean, you are not going to think like the everyday person. You are not just going to think like everyone else as in average, or you are not just going to think in terms of the calculation of mean, but you are going to understand the significance of mean. The word mean is going to mean a lot to you as a data scientist and a data student. When you hear the mean, you will know what it means. You will know it gives you a lot of information about the data you are dealing with. And when you are doing analysis and you have not seen the mean, you are not going to be satisfied because you yourself, you'll be looking for the mean because the moment you get the mean, it helps you understand the data. Yes. So very soon, you are going to do more of statistics. And in statistics, we have the max, we have the mean. And in Pandas, you can easily use these functions, dot mean, dot max, dot mean, to get the descriptive statistics. Please type descriptive statistics in the chat for me. Type descriptive statistics in the chat for me. Type descriptive statistics in the chat for me. All right. Thank you very much. Sometimes the way I speak just in a way so that I can communicate more to beginners. Okay. I can communicate more to beginners so that as beginners get to this level, they will understand, especially this video, beginners will understand what we are talking about because it depends on where we are in our studies. And sometimes I can communicate more in advanced terminology. So we are going to look at statistics, descriptive statistics. We are going to talk about inferential statistics and various types of statistics as we move forward. All right. So in Pandas, you can also filter series based on a condition. Based on conditions. So we have a series called grades, and you can show all grades above 80. And this is very, very simple. We did it last week. All right. So now we are going to move into data frames. We are going to talk a little bit more about data frames to fill in the gaps of what we need to know about data frames, especially creating data frame from scratch. Creating data frames from scratch because we need to know how to create data frames from scratch. Not only are we going to be reading from file, we are also going to know how to create data frame from scratch. And this is really, really important to prepare you for advanced education in handling data. So let's type data frames in the chat right now, and let's move on to the next step in our training. If you are here and you have no idea what data frames are, we are talking about pandas, and we studied that pandas structure data into two structures, or pandas renders data into series and data frames. And so we are talking about the data frames data structure of pandas. And a pandas data frame is a two-dimensional labeled table that allows you to store and manipulate data in rows and columns. This is very similar to Excel spreadsheets. You've seen how spreadsheets are, or a SQL table. Those of you who have some background in SQL, it's just like a SQL table or an Excel spreadsheet. So when we talk about series, series refers to one column labeled data, and data frames refers to multi-column, or what we call two-dimensional labeled data. Very soon, we are going to pay attention to what is meant by two-dimensional and what is meant by labeled. All right. And you can see that it stores data in rows and columns. A data frame is called two-dimensional simply because it consists of rows and columns. So when we say 2D or two-dimensional, we are talking about rows and columns. We are not saying it has two columns. We are saying that it has rows and columns. So it could have multiple columns and multiple rows. We call that 2D. 2D. Anytime you hear 2D or a 2D diagram, it is simply talking about a flat diagram. A diagram with a width and height is referred to as two-dimensional. When we say something is three-dimensional, then it has more than width and height. It has another dimension that makes it look like a body. Yeah, so this is a two-dimensional data structure, and it gives you rows and columns. All right. Now, each row represents a record. And so each row here is one record. So when we take this, we are taking one record, and the record could be a single student, a single product, or a transaction. So if you are dealing with students table or students data frame, a single row here will refer to a single student within the data frame. If we are talking about products, a single row will refer to a single product in the data frame. And each column represents a feature or a variable. So a single column represents a feature or a variable. So this particular column that I just wrote through, what is the column name in this particular data frame that we see here as an image? What is the column name? All right. So this column is referred to as apples. So this apples here is referring to a variable within the data frame. So long as that is a column name, we can call that a variable or a feature or a column. You can also use the term column in the data frame. If you are in a student's data frame, one column could be the name. Thank you very much. One column could be the name, or one column could be the age, or whatever column you are referring to. Also, a data frame is called labeled because both the rows and the columns have labels. So we said it is two-dimensional labeled, and we've explained the two-dimensional. The two-dimensional means it is made up of rows and columns. The series, which is one-dimensional, is made up of only a single column. Now, it is also called labeled because both the rows and the columns have labels. The label of the row is referred to as the index, or what we call the indexes. So please type index in the chat for me. Index. So this index is the label for the rows in terms of data frames. Now we are referring to data frames, not series. So this is the labels for the rows, and the columns are also labeled using what we call column names. So you can see that the apples you see here is also the label for the column. All right, so when it comes to data frames, this is how we consider the labels. And this makes data frames powerful as you can use the labels to slice, to filter, and to analyze the data in a way that is more intuitive and readable. Because of these labels, we can filter, we can slice, we can manipulate the data in multiple ways. All right. The lesson here is for us to know how to create data frames from scratch. And so we are going to switch to our Jupyter environment, and we are going to start creating data frames from scratch. So if your machine is ready, please turn on your Jupyter notebooks and let's get ready to write some code. So let me set up my Jupyter. I'll just use my terminal. Let me open to this environment here. And I will go to my terminal and type Jupyter space lab. And then my Jupyter lab will start. All right. So once I have the Jupyter lab here, I'm just going to go ahead and start a new notebook. And I'll make this a markdown and say that creating a pandas data frame from scratch. All right, shift enter. And then we'll go ahead and we'll start creating our data frame. So let's take a look at the first thing you do when you want to create a data frame. Now, who can tell us the first thing we should do? I'm sure everybody is aware, but what is step one if you want to create a data frame? What is step one? All right. So of course, Francis says we need to import pandas as PD. So this is very, very simple. So let's step one, import pandas. So you just say import pandas as PD and you run it here and then it runs. If you see the number, then it worked. All right. Now, if you don't have pandas installed, then you have to install pandas, obviously. So who can tell us the code to install pandas in Jupyter environment? Right here, we can install pandas. Who can tell us the code to install pandas? Who can help us? Let me see someone in the chat. I'm sure everybody knows, but just by the way, because sometimes we have new people join us. All right. So to install pandas, Anthony says pip install pandas. All right. Which is wonderful code. Pip install pandas is really, really wonderful because this is actually, I wrote PHP. I like PHP. All right. So pip install pandas. This is good code. And this is a code we use to install pandas. However, this is a code you use when you are in your terminal or your command prompt. So in my command prompt, in my command prompt, I can go ahead and say pip install pandas, and this will work. This is valid. This is valid code. And you can see that it will try installing pandas. If I already have it, I will see this that says requirements already satisfied. So this is good when you are installing from your terminal or command prompt. However, in Jupyter environment, you need to add exclamation here before it will work. So to run it, you can just click on run or shift enter and it will run it for you. I'm going to type the same code. Let me delete it. You can see that requirement already satisfied. This means I already have it. So if you don't have it, then you will install it. I'm going to press DD and delete it. And I'm going to type the same code again. I'm going to type pip install pandas. And sometimes when you are working on certain projects, you need to add this to it because you do not know where the code is going to be or where the notebook is going to be used. Sometimes after creating your notebook, you need to share your notebook with others. All right, let me move this upwards. You need to share your notebook with others. And so you don't know whether that person has pandas or not. All right. So sometimes if you are creating a notebook that will go out, you need to add your install code to it. All right. Now, sometimes you do not want the code to, you do not want the code to run and show all of those. You do not want the code to show all of those information when it is installing. Now, I am seeing this because there's a notice of a new version of pip. And to run it, I need to use Python to run this and upgrade my pip. Let me do that and see if it will just stop. So over here, let me clear and let me run this. So I have pip install. Okay, so I just use Python -m, then we do pip install --upgrade pip. All right, so let's run this and it is upgrading my pip. Let us upgrade it. And let me come here again and run this and see if the notice will show. All right, so sometimes you are notified of this thing is showing because of my antivirus. Don't worry about it. All right, so you can see what just happened here. If not that I had to upgrade my PIP, you could see how I've written this installation code and it worked. It was working. You could see that it was running like this. When you see the asterisk, it means it is running. When it is done running, then you see the number. But we didn't see the output and it didn't distort our notebook in any way. Sometimes your notebook could be a very, very professional looking document and you don't want certain codes to mess it up, especially when you are installing something. Who can tell me why this installation worked without showing the messy output? Who can tell me why? Just put it in the chat and let me see. And this is the reason why I just wrote this. All right. So someone says because of the quiet. All right. So this is a flag that will make it quiet. And this is very important because sometimes in a professional looking Jupyter notebook, you need to silence some things. All right. Now we are going to really create our Pandas data frame from scratch. And to do that, the first thing is to import Pandas, and we are going to create our data frame from a dictionary of lists. So over here, we are going to create a dictionary called data. And this particular dictionary, it is made up of lists. And so the key is going to become the name, and then the values will become the values within the list. So let's go ahead and create this. So please, let's all work together. You create your dictionary, create your pd.data frame, and then you share in the chat. So let me go ahead and create this dictionary. So this is just a dictionary. This is not the data frame yet. This is just a normal Python dictionary. And so we are going to create this dictionary called data. So we are going to create a data frame from a dictionary of lists. Dictionary of lists. So I'm going to create my dictionary. It's called data. And if you know anything about dictionaries, you need to use curly braces. And these curly braces, once you open the curly braces, you've started a dictionary in memory. What you need to do is to give it the keys and then colon the value. So the key, because it's a string, I'm going to call it name and then colon, and then the value is going to be made up of a list. When I'm done, I introduce my comma, then I create a next key. My next key is going to be called age, and the next one will be called city. So my next key, also a string, I call it age, colon, then comma. The next one is going to be city, colon. So these are the keys, and the list here is going to contain the value. So let's go ahead and put some names in there. Let me see how many names we have here. We have 3 names. Let me pick 3 names from the class. And I'm going to start with Robly. Since it's a string, you need to put the name in quotes because you are dealing with strings. So we have Robly. And then we also have, let me see, Rubin. And of course, we have David. So these are the first 3 names I saw. Yes. So the ages, I'm just going to guess some ages, 10, 20, 30. And then the cities, Robley, tell us where you are from. So we'll put Robley in this string. We'll put Rubin here, and we'll put David here. So Robley is from Nairobi. How about Rubin? Okay. Ruben, where are you from? Okay, Ruben from Ghana, of course, from Ghana. We miss you, Ruben. And David, where are you from? David is also from Ghana, right? All right, so David from Ghana. All right, so what we see here is just a dictionary, okay? So this is a dictionary. So let me just call this the dictionary. So this is the dictionary. And then after the dictionary, we'll go ahead and now create the data frame. Now, to create a data frame, this is where you now introduce your pandas. Okay. All right. So the pandas that we imported as PD, this is where we call it PD. And then there's a constructor, which is also a function called data frame. You have to call that constructor. That is why they call it class over here. And you need to put it in parentheses because it's a function as well. And then you feed your data into it. So this is how you create this from scratch. And of course, this is how we've been doing. We have several functions that allows us to create data frames. So this one, it means you are creating it from your own data. All right. And since we need to provide rows and columns, this keys here will represent the columns, and then the values here will represent the rows. And this will be created in memory, but we need to store it somewhere. And by convention, we can use df to store it. And let's run it and see if we'll get an error. If we don't get an error, then it worked. So I'm going to run this. If you see the number, then it worked. So it worked, and I can see that TestFit is doing so well. TestFit has already gone ahead and done it. Thank you so much. That's a plus. Thank you, TestFit. The work is great. So let's come here and call our DF, and we'll run it with Shift Enter. And you can see that we have a beautiful data frame. So this data frame you see here, we didn't read it from a file. We actually created it from scratch. Now, we learn these kind of things because sometimes you need some prerequisites to be able to do some advanced learning. Okay. So as you see these things so simple, so basic, and why we are doing them, it is because there are some advanced studies that you'll be doing that you are not going to be importing data. You are going to use the data frame constructor. You are going to create a data frame from scratch. And if you've not done it before, you will see that it will be hard for you to follow the lesson. By the time you wrap up your mind about how that was created, the lesson has already made progress and left you. So you can see that even though we use this as the column names, in a data frame, different index numbers were created. We saw that index numbers were created over here. So these are the index values over here. So this is one interesting way of creating a data frame. Let's see if there's another way we can create a data frame. Now, this is the most common way you'll be creating data frames from scratch if you'll be doing it from scratch. This is the most common way you'll be doing it. Now, we can also create a data frame from a list of dictionaries. So the previous one was from a dictionary of lists. Now we can also create it from a list made up of dictionaries. Let's see how this will work. This is going to be interesting. So please create this and let me see how it will work. This is going to be interesting. Create this and let me see how it will work. So with this one, let's go ahead and create the data, which is a list. It's a list because it's made up of the square brackets. And you can see that these are the values of the lists. These are the values of the list. So this is the first value with comma, and then the second value also here. Let's see how this will work out. So I'm going to create data, second one. Let's go ahead and create data. And this data is actually a list. Let's see how this will work. Okay, someone has already done it. Wow. Wow. Okay. So here I have my first value, which is a dictionary. So name, Alice, age 25. I'm going to change the names. So my first dictionary here, this is a list of dictionaries. So my first dictionary will be here, sorry, comma. Then my second dictionary will be here. But this is a list. If you check the data type, you'll be told that this is a list because it's made up of square brackets. So here, as a dictionary, I'm going to have my key value pairs. So my first key will be name. Then the value will be someone else. Let me use that. And then I'll create another one with a key of age. And then I will just give it an age of, I'll just give it an age. Zeph, let me give you, let's assume Zeph is 11. Let's just assume. All right, so I've created my first dictionary successfully. Let me create another one made up of name and age again. And this one here, let's call this Ibrahim. And then we'll create the age to be 21. All right, so this is data. This is data. Sorry, I wanted to write a comment. So let's say creating a data frame from a list of dictionaries. Wow, this is so interesting. So we have our dictionary here, our list here, and let's go ahead and create it the same way as we created the first one with the same code, and we'll see how that will work. So we call our pd.dataframe, and then we put in our data. Let's store it in df. Let's run it, and it worked. And let's call df, and let's run df, and df worked. Wow, this is so interesting. Okay, so in this lesson, we've seen two ways that you can create a data frame from scratch, either from a dictionary of lists. This means you created a dictionary which is made up of multiple lists, or you created or from a list of dictionaries. So this is a list which is made up of multiple dictionaries. All right. Over here, we just have to be sure that the number of items here are uniform and the keys are also the same. Esimame, you are so smart and serious. Thank you so much. All right, so you can use any name you want. It's fine. I just chose these names because they were the first in the chat. That's why I just chose them. All right, so we've seen two ways of creating data frames, and we can see the second data frame here. Beautiful. Let's see the next one. The next one says that you can also create a data frame with custom index. All right, so what this means is that we need to take note that we have another parameter in the data frame function, this function here, which is a constructor. This function, it can accept a second parameter. So we've been using the first parameter here called data. This is what we've been using, but it can also accept a second parameter. This second parameter allows you to manipulate the index numbers or the indexes. This is so interesting. So you can give it any name you want. Here we give it ABC. And here we call it S1, S2, S3. This is just to tell you that you are free to give it any name you want, like math, English, science, it still works. And this is very important because sometimes you can manipulate the indexes or the labels. You can manipulate the labels. This is really, really interesting. So let me see the third one we will create. Okay, so this is a little different. So what I'll do is I'll go back and I'll try and manipulate the labels and see how that works. So over here, since we know that we have, just two items, we can call the second parameter. Please take note that this is just a function. It's in capital because it's a constructor. We'll talk about constructors later. You just call the index parameter and you can go ahead and put the index in a list. Okay, so we can just say A, comma, B, or first, comma, second. Let's run this again, and let's run this again. And you can see what happened here. The A has replaced the 0, and the B has replaced the 0, the 1. So this is important to tell you that in creating a data frame, there are multiple parameters. So far, we have seen the data or the first parameter, which accepts the data. And we've seen another parameter that accepts index and allows you to manipulate the index numbers here or the indexes. We will introduce another parameter that can manipulate something else as we make progress. Again, these kinds of data manipulations are very important and they are prerequisites for other lessons. So when you're learning things like this, you just have to understand that they are just foundational studies that will help you to do other studies. All right, so just take them that way. Don't see them, thank you, Esimame, that's wonderful. Don't see them as too simple or too, they may be simple, but they are very, very important. Yeah, so just practice them. Whatever we are doing, practice them. Whether they are too simple or not, please practice them. All right, thank you. And Koleko, thank you so much. All right, so the next one here is from a dictionary of series. All right, so let's pay attention here. Thank you, Francis. Thank you. You can see that we have a dictionary, but this dictionary is made up of the key, which is a name, and then a series. You can see how we created a whole series and we use a series to create the data frame. Wow. Already we know that series are made up of single columns and multiple columns can come together to form a data frame. So this is another way that a data frame can be created. If you have not seen this before, as a prerequisite for higher education, you may see this and be totally confused. So please create this for me right now. After we create this, we are going to introduce another way of handling this. Of course, if I should ask you, you can tell me that why can't we create a series first and then use a series to create a data frame? That is also possible. For now, let's create this and let me see who will be the first to create this on the screen and share with us. So just create the same thing and let's see it. Again, this is foundational studies for higher studies. So Take it seriously. Take it seriously. And make sure you practice everything. All right, so I'm waiting for the first person who will share this with me. Let's see how your data frame will look like. Let's see how your data frame will look like. Okay. All right. So the first person to create a data frame from a dictionary made up of a series, the first person okay. Let me reload my chat to see who won this. Let me reload my chat and I'm going to give this to Marasi. Marasi is already behaving like a senior. Wow. 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 Marasi is a genius. Wow. I love that. I love that. All right. So Marasi, congrats. And Robly, congrats. You've all done very, very well. And you can see that it worked. Norbert, thank you so much. You guys are working. You guys are working. Yes, you guys are working. All right. All right. So when we are in class like this, you guys are seeing me, you are seeing my screen, but sometimes we don't see you. And so sometimes we are going to request for one of you to record yourself whilst you are in class live. Okay, just put a camera behind you to record just a small part of you in class. Okay. And we are going to write a day in the life of, let's say, Francis in a Rita Africa Python class. All right. So whilst we are in class and we are coding, the instructor is speaking and you're also speaking, we want to show how it looks like when a student is in class because we are all behind the cameras and we don't see anyone. So very soon we are going to be requesting anybody who has a 9 setup, you can just put a camera behind you and just record a 2-minute video and just share with us at info@retailafrica.com. And then you let us know a day in the life of this, and we'll write a short story and publish it for you. All right. So all of this will help you in your profile. Okay. Once you see it on Rita Africa, you also repost on your platform as well. Okay. So you've all done well. Let's go ahead and create this. So this is interesting. So with this, the data we are creating, the data we are creating today is actually a dictionary, which is made up of a series. That's so interesting. So what we are going to do is that with a dictionary, this is how we start a dictionary. When you hit enter, it will put one down and allow you to create it here. And we use name and age. So I'm just going to create name, then column. Then we'll put our series here. When we are done, comma, then we'll come to the next one and we'll create age, column, and then we'll put our series here as well. So to create a series, we are going to start with pd.series and open our parentheses. And the second one to pd.series and we open our parentheses. So over here, we are employing Pandas directly. for this series. So we call our pandas pd.series. Now, series here is also a constructor, a function. And then this one too will be pd.series. Then you open your parentheses. Now, inside the parentheses, there are some parameters that you are required to provide. Some parameters you are required to provide. And so the parameters you are required to provide, the first one is the data parameter. And you can see that we enter the data directly in the first parameter. The second parameter is the index parameter. And with the index parameter, we use this index and then we entered the numbers. All right. So the data parameter, we use a list to create it. And then the index, we just created the index like that. So what I will do here is to come here and use a list for the data parameter and then call the index for the index parameter. The index also has to be a list like this. And then we give it 0, 1. Here too, we do the same. We create a data parameter like this. And then index, we use the same 0, 1. And we are done with the index parameters. For the data parameters, we are going to put some names in here, 2 of them, because we have 2 index numbers. So I'm going to use ATO here, comma, ATO, and I can see ZEP. So ZEP has been 2 times on my in my charts as first names, and the next list is going to be their ages. So let me call ATO, let's say 15, and let me call ZEP this time 17. All right, so my data is created. My data is created, which is a dictionary. And what I'm going to do is that I'm going to comment it and say creating a data frame from a dictionary of series. All right, so now that we have our data, we just say pd.dataframe now. And so in this particular code, we've had a chance to use .series and .dataframe all in the same code. All right, so now we just go ahead and input our data and store it in DF. And let's run this and see if everything is all right. And it worked, everything is all right. Let's see DF. And when we run DF, we see ATO and ZEF. This is beautiful. This is beautiful. So all of these will allow you to get exposed to what is possible and what you can do with your data frames. All right, so we'll be done with this very soon, and then we will quickly go ahead and do some basic manipulations or operations, and then we'll wrap up. Now, someone will ask, why don't you create a series first before creating the data frame? So in the previous example, thank you, Mr. Okoka, you can see that the same thing is done here, just that we went through step 1 by creating the series, the names and the ages for Alice and Bob, or Ato and Zeph, and then we created the ages as well. Then when it came to creating the data frame, we called the data frame and we passed the dictionary directly into the data frame like this. So this is also possible. So we are not going to create the same as what we did previously. All right. Next, you can create your data frame from a list of lists as well. Now, one thing about list of lists is that it doesn't have the key, which will be used for the column. And so you have to introduce the columns parameters or columns parameter. What this means is that in the data frame constructor or function, so far we've seen 3 different parameters within this particular function. The first one is for the data, okay, whether you use a variable or you enter the data directly. The second one is columns, which we are looking at right now. And what is the third one? Who can remind me of the third one? Okay, so someone says using collab. I got it. Wow, it looks beautiful. What is the third parameter that we've seen so far tonight in the data frame constructor? Is called index. Thank you. So there's a parameter called columns that you can call if you wish to, because if you call these columns, you can use it to create a list from a dictionary, sorry, a data frame from a list. You can use it to create a data frame from a list of lists. All right, so someone should create this and let me see how it looks like. We use a list of lists. Because we don't have the columns, we have to add it to the data frame constructor over here. So let me see the first person who can create this for me, and then we will move on to other interesting ones. Wow, Esimami. Wow. I like the way you always go beyond what we are even asking. You go the extra mile. I love that. I love that. Esimami, you're doing so well. Okay. All right. So Esimami has done it. Let's go ahead and write our own code. So let's come here and we'll go ahead and create our data. Our data is made up of a list. And we have two lists here as well. So my first list will be here, comma, and then my second list will be here. My second list will be here. All right. So my first list is made up of a name and an age. So I'll just go ahead and input the name, comma, and then the age. So the name here, let me see the first name here. I see Atu again. And Atu, let me give Atu 13. And then I see Robly. Let me give Robly 21. All right. So over here, we have a list of lists. This is also possible, list of lists. So let's add a comment here and say that creating a data frame from a list of lists. All right. So let's go ahead and call our pd.dataframe. And we'll call the data parameter and we'll call the columns parameter as well. And with the columns parameter, what we'll do is that we'll go ahead and input the columns, name and age also as a list. So over here, we'll just provide the first name, comma, age as a list. So the index is also receiving a list, and then the columns is also receiving a list. Over here, we don't need to use index. It will work. If I run this, it's going to work, but the data is going to be lost in memory. And so I'm going to store the data somewhere in DF so that we can refer to it later on. So let's go ahead and run this. It worked. And let's call DF and run DF, and it worked. All right, so this is beautiful. So we've seen how to create a data frame in multiple ways, how to even change the indexes here, the labels here, and this is so interesting. All right, you can do the same with a tuple, the same as a list. So I'm not going to create this. Thank you, Zeph. Thank you. You can do the same with a list of tuples, and it's going to work. The same format, just I use a tuple. All right. So we are going to perform some very basic operations, and then we'll wrap up very soon. The first operation that we are going to perform is this. We are going to be accessing the columns, and this we've already done before. We just want to relook at it. Now, if you have your data frame, you can access the columns by typing the name of the data frame variable and then the column name. If you want to access two columns, then you can use the double brackets and you can enter the 2 columns in the middle bracket. My question to you is that why is it that when we're accessing the first one, we use a single bracket? And why is it that when we're accessing the second one, we use double brackets? Who can tell me why? Okay, thank you. Zeph, you're also doing so well. Thank you. All right. Okay. Okay. All right. So we've already seen this before. If you access a column within your data frame with a single bracket, what this means is that you want to return a series. Because it is a single bracket, it will extract it for you in a different data structure called a series, and you can store it in a different variable. Now, with the second example, you can see clearly that we are not accessing a single column, but we are accessing multiple columns. So you can't make this a series. Because it is multiple columns, you have to use double so that it returns a data frame. And we didn't use 2 because we are accessing 2 columns. It doesn't mean if you're accessing 3 columns, you need to use 3, or 4 columns, you need to use 4. No, you just need to use 2. The 2 represents a data frame. All right. One question. If we are accessing a single column, can we use 2 brackets to access a single column? Yes or no? Can we use 2 brackets to access a single column? Yes or no? Can we use 2 brackets? Okay, Marcy says yes. David says yes. And who else? Ismami says yes. Who else? One more. Um, one more. Okay, Kulako says yes. So yes, you can use 2 brackets to access a single column, but what will happen is that in memory, it is going to return a data frame to you instead of a series. This tells us a whole lot because a data frame can also be made up of a single column. It's possible. It's possible. So if you use a single column and a single bracket, then it is going to extract a different data in a different data structure. That's why I use the term different. It's going to extract a different data structure for you called a series. But if you use 2, you are going to get a data frame. Now, if you have 2 columns, then you cannot use a single bracket. If you have 1 column, you can use double bracket or a single bracket. But if you have 2 columns, then you need to use double brackets to access it. Let's try that and we'll talk about what is at the bottom here. So over here, we have name and age. Let's try accessing name. Let's try accessing name. So we'll call df with a single bracket and access name. Okay. Let's run it and you can see that it worked. You can see that it worked. Okay. Let's print it. It worked the same way. But let's print the type of this. And you can see that it told you that this is called a series. This time, I'm not printing the data, I'm printing the data type. It told you that it's called a series. If you use a double bracket for a single column, let's check the data type. The same thing worked, but it's telling you that this time it's pulled column, but it pulled it into a different data structure called data frame. So it is possible to use 2 columns to access 2 brackets to access a single column. And it worked beautifully here as a data frame. All right, so let's add age to it and see how that works. And so this also works beautifully. Okay, this also works beautifully. So that is clear. All right, now let's look at what is at the bottom here. It says that if you are dealing with a single column, you can also say df.name. It also works if the column has no spaces. So we can also do the same thing here and say df.name. I think we'll just print it rather, okay? But it worked already because df is the data frame storing this data and name is already known. You can say df.h and you can see that that also works. Whether you print it or not, it also works. So this is fine. If it doesn't have spaces, you can also do it this way. That is for single columns. Okay, we don't do this for multiple columns. So if you are targeting a single column, you can call this. Okay, you can just say .h. You can just say .h, and instead of using df, it will work. And sometimes you are looking for other things like main, and you can see that instead of using the brackets, you can just say .h.main and it worked. Okay. Why can't I do .name.main? Who can tell me why I cannot do .name.main? Who can tell me why I cannot do .name.main? Okay, so someone says his worked. That's beautiful. Okay, that's beautiful. I'm so proud of you. Wow. Okay, that's wonderful. Okay, so I'm asking a question. Why can I not do .name.main? I've not run it yet. Why can't I do this? Anybody? Okay, sorry. I was reading from a different chat. All right, thank you. Okay, so it's not a number. All right. So sometimes when we do some descriptive statistics, okay, when we do some descriptive statistics of a data frame, like this one here, df, if we say dot describe, if we do some descriptive statistics, we are going to see statistics of the whole data frame, but it will run the statistics only on the numerical columns. You can see that this data frame df is made up of name and age. How is it that I call df? I didn't say df.h.describe. I said df.describe, but it gave us only age. Because these statistics are only run on the numerical columns. So even if you have string columns, it will remove them and give you the statistics only on the numerical column. That is why the mean, I was able to do the mean only on the numerical column. All right. So let's run this first two. Someone should run this first two. Sorry. And then we will go ahead and discuss it. And we'll have just a few and then we'll wrap up. Someone should run this and let me see. All right, so it works for the integers and the floats, the numerical column. Thank you. All right, so let me see who can run the df.log and the ilog and just share and let me see what you got. Ato, thank you. This is very, very powerful. Okay, wow, that's so beautiful. And the ilog, that's so beautiful. All right, so you can see that the dot log allowed you to access the row by the label. And we'll discuss what we mean by the label. And then also the ilog, when you use ilog, it means you want to access it by the position. Let's try it and see what that means. So let me go ahead and type df.log, df.log, and then we will access it by index 0 over here. When we run this, we are going to see that this is going to access, let me delete this describe for now. Okay, by index 0, we have Ato over here. So it gave us name Ato, age 13. So it gave us a row, and obviously it is adding the columns to it just for us to know which columns they are. Then we have df.ilog. df.ilog is also accessing the same data, but if you use the ilog, it means you are looking for the index position. So if you use 0 here, you can see that both of them have 0, but the log has a meaning and the ilog has a meaning. If you use the ilog, then you are specifically talking about the index position. If you use the log, it means the label name. This is important because sometimes the label name, sorry, this is important. Someone is saying that, hey, is there homework? This is important because the label names, sorry, let me share my screen well. I don't know what you are seeing. This is important because the label name, the label name can be a string. So over here, you can see that the log, if you use a log, it doesn't necessarily have to be an index value. It can be whatever the label is. If it is a string, you can put a string over there. And if it is by position, then you need to use the ilog. So this is important. Again, this particular lesson, we've designed it as a prerequisite for higher studies in advanced learning in data, okay? It could be for machine learning, it could be for data analysis, it could be for cybersecurity analysis or anything. So let's keep all of these in mind. Next time, when you see ilog with your pandas data frame, you know what that means. And if you see log, you know what it means as well. All right, so this, we've already done this. You can filter rows. You can filter rows. So let me see someone do this. You can filter rows. So you call your DF, and then out of the DF, you pick a column, and then you pick a column out of your DF, and you say where it is greater than 28 or any number at all. So this is called filtering. You can filter rows. You can filter rows. So let me see you do it and put it in the chat for me. So over here, the ages, let me use 15 to filter. So we can go ahead and call our DF. And within our DF, we'll call one column. We know how to select a column. We'll type DF and then the name of the column. This column is called age. Okay. So this is how to select the column. And we can say where age is greater than 15. All right. So thank you, Francis. Thank you, Zeph. Okay, so this is so nice. When you run it, you can see that only roughly came out of VF because this is filtering. So this is filtering by row. Filtering by row. All right, that's beautiful. That's beautiful. That's beautiful. So over here, you can see that we call DF and everything is within the DF. Then within the DF, we set this column, which can also be selected with DF again. This column greater than 15. That means you should select only this column where the values are greater than 15. All right, so it worked beautifully. Where am I? Then you can also filter rows by string, filter rows by string. So let's run this on any of the name columns that we have, and let's look for somebody's name. So you can filter rows by string. So in this particular data frame here, we are using cities, and you can call Lagos. But with what we have names. So you can use name and put somebody's name and see who you'll get. So let me see Zeph. Let me see Esimame. Let me see anyone who can filter by someone's name. And this is so beautiful. It's like writing a query in SQL. You can just filter, select a particular query by name. All right, so let's see anyone who can select someone by name in our data frame. All right, so the first person is Francis. Okay, so Francis was able to fetch someone. Let me see the person. Francis was able to fetch Alice. All right, that's beautiful. All right, so let's go to our code and see. It's me, David. Thank you. All right, that's so beautiful. The way you are writing the code, you make me feel so happy. So we are going to filter rows by string. And it's very, very simple. Remember your DF selection. So we'll go ahead and call our DF. And within our DF, we'll call another DF with column name. And we'll say the name is equal to, this is double equal to, and let me call Zeph. I think I have Zeph in my DF. Do I have Zeph? Of course I have. Okay, Ato rather, because we overwrote it. All right. So we have this, and I was able to pull Ato out of it. Thank you so much. Okay, so I'll put that back in. Don't worry. All right, so let's do this. This one is saying multiple conditions. Selecting with multiple conditions. Please do this one. All of these things are prerequisites for higher learning. So please do this. Okay. So we have age greater than any age, and then we have name equals to something else, all within your DF. So let me see the first person to do multiple conditional filtering. Okay, that's beautiful. You guys are doing so well. What we are learning, I want you to spend another time going through them. Tomorrow you will understand. you understand that these were prerequisites, foundational studies for higher studies. So let me see the first person who can do a multiple selection. Okay, so thank you. Thank you. All right. So this is wonderful. Thank you, Ato. Ato was the first, and TestFit also submitted. So we have DF selecting age, and we'll also select name. So let's go ahead and filter. So filter rows with multiple conditions. So I'm going to write filter rows with multiple conditions. All right. So what we will do here to call our DF. Within our DF, we are doing multiple selections. And so what is going to happen is that we are going to use the AND operator to do multiple selections. So we'll have our first one in this bracket or parenthesis here, then the AND operator, and then we have this. All right. So over here, we will select by name. Is it name or age? Okay, by age, and then the second one will be by name. Okay, so let's go ahead and type our DF here. And with a DF, we'll know that we'll select the column name. Okay, and then this age, we can say age is greater than 15. Okay, age is greater than 15. You can do it like this. And then you come into the second one, and then you run another DF. And this DF, we do it for the name. And then we'll say name is equal to probably. So let's run this and see if it works. And this particular item met both conditions. The name was correct, probably, and the age was greater than 15. It worked. It worked. This is wonderful. Okay, this is wonderful. So when it comes to descriptive statistics, you can run your statistics on the column or on the whole data frame. Sometimes you can select a column and run okay. All right. So we can run descriptive statistics as well. And you can run it either on the whole data frame or on a single column. Remember, you can just, if it's a single column, you can also do dot the column name, and then it will work. So the describe is there for the whole data frame. And we also have dot mean for the age, dot mean for dot max for the age, dot mean for the age. So any numerical column, you can do these statistics on. Okay, you can do these statistics on. Yeah, so that is how it is. You can run the statistics on a column or on the whole data frame. So let's try this. We've already done it. So let me just go ahead and move on. We've already done this. And the last one we'll try is to plot a histogram out of this particular data frame. And we are not going to import matplotlib. We are going to plot a histogram out of the data frame with just pandas. All right, so someone should create this right now for me, and then we will wrap up. This will plot the data frame and plot a histogram. And you can see that it will plot it even without using matplotlib. And later we'll discover that even if you don't import matplotlib, pandas alone by itself can create some visualizations using matplotlib under the hood. This means that there are certain visualizations that even if you don't import matplotlib, pandas alone by itself can do it. So this will help us prepare for data visualization using pandas very, very soon, and matplotlib and other libraries. So just plot this and let me see what you will get. Call it a hist, meaning a histogram, and then give it a bin of 5 or a range of 5. So the technical term is bin. If you say bin, it means a range, and then the title. And so a time will come, we'll be doing a lot of plotting, and you will see that it's going to be very easy for you to create plots in your Python code. It's going to be very, very easy for you to create plots very, very soon. Now I'm happy we are making progress with pandas and data manipulation. But very soon, we are going to understand all of these visualizations very, very soon in pandas. So let me see the first person to do this. This is the last operation. After this, we will just go straight and I'll give you your assignment and you will take time and work on it and submit by Wednesday next week. So I want to see the first plot. Whoever will give me this first plot, I'm going to appreciate you. Let me see the first person to create a plot. So you create this from a dictionary. Even though it's a single column, you know that histogram is an analysis on a single variable. And we just want to know the frequency of the various bins or ranges. So Nkuleko got it. Nkuleko, where are you from? Nkuleko, where are you from? Let me give you a shout out. So our visualization was created by Swaziland, Nkuleko. Thank you so much. From Swaziland. Thank you. That's beautiful. So Atul also has his visualization. That's beautiful. So Marasi. Okay, so Marasi has also done it. So Marasi, did you import matplotlib? Tesfi, did you import matplotlib? Let me know in the chat. Isimami, did you import matplotlib? I think Isimami is on Colab, so no. So Tesfi says no. Marasi says no. So even without matplotlib, so long as you're in your Jupyter environment, you can even create some plots. Now, what I'm telling you is that these plots, Pandas alone can handle it, but it is doing it with matplotlib under the hood. All right. And so Sometimes with the plots, we can go ahead and use Pandas to start it. And sometimes we will introduce Matplotlib. Most of the time we use Matplotlib. We are just learning the capabilities of Pandas right now. That is why we are talking about this. All right, so let me go ahead and do my plots, and we will be done with our lesson for today. So we are plotting a histogram of a column. So plotting a histogram of a column using only pandas. All right, so I'm going to create this data frame. df equals to pd.dataFrame. And then this data frame is going to be a dictionary. So I'm going to go ahead and create my dictionary. And this dictionary is made up of, it has a name first. The name is called, is this course or what? Okay, it's course. And then it has some numbers. Okay. So who can remember the numbers? Put it in the chat for me so that I don't switch my screens. So we have scores, column. Then I create my list here and then multiple numbers. I know the first is 75. And then we have 85. Thank you. 90. I think it's okay. Then 95. You guys are so supportive. 70, 60, 85, 88, 92, and 76. All right, so this will create my data frame. And after creating my data frame, I'm just going to pick that column and say dot plot. So I'm going to pick that column and say dot plot. So I'll do my df of that column. And let me see if it was done on as a series or data frame. Okay, so I just do this on scores and say dot plot. That is it. So this is a code to do the plotting. Dot plot. Now, when you do that plot, you need to go ahead and provide some parameters. So let's see the various parameters. How many parameters do you see over here? If you can see the parameters, tell me how many parameters you see. How many parameters do you see here? All right, so Marasi says I see 3 parameters. One is kind, the other one is bin, and the next one is title. Now, this bin is usually tied to histograms because histogram wants you to tell it the range. So the range in Python, we call it bins, or in statistics, we call it bin. So kind, bins, and title. So I'll go ahead and look for these 3 parameters in dot plot. So what I want you to remember is dot plot. So we'll say kind equal to a string, comma, then bins equals to a string. Okay, bin can be an integer. And then we have the title equals to a string. All right, so the kind is hist, bins 5, and then title is called distribution. So here, kind is hist. So this is the keyword for histogram. If you want a bar chart, you can just use the keyword for bar. We'll look at all of them. Histograms specifically have bins, meaning the range. And then for title, you can just say it's called distribution. All right, so we have this, and let's go ahead and run this, and voila, we have a beautiful plot. Are you enjoying the lesson? This is beautiful. And over here, I know that you can see the range we got from 60, 65, from 65, 70, from 70, 75, 75 to 80. So that's the bin or the range. And it worked so wonderfully. We know how many people got the first range, just one. Second range, one. Third range, one. But the fourth range, we had about 2 people And then 90 to 95, we had 4 people. Wow, let me access the data. So from the data, you can see that we had over 4 people. One, two, three, 4 people from 90 to 95. One, two, is it 90 to 95? Okay, so 90, okay, okay. So it's from 80 something. All right, it's not 90. Wow, that's beautiful. So this is a plot, and this is wonderful. So very soon we are going to be doing a lot of plots. This is just introducing us to the world of plots, and very soon we'll do a lot of plots. In our data classes, we are studying about plots. Tomorrow we'll be talking about box plots, also referred to as box and whisker plots. Very, very important for statistical reading. So in tomorrow's data class, we'll be looking at that. Don't miss it, because if you miss it, you are going to miss a lot. And all of these things, they are linked together. Okay. Everything we are studying these days, they are tied together. What we are learning here, you can see that it's connected to the data science class. What we will learn tomorrow, you can see that it's connected to the data science class. And all those things are linked. What we'll do in the math class, you can see that it's connected to the data science, and it will make you understand what we are doing. Yes, and everything is going to make sense very, very soon. So the last thing we are going to do is for you to do some student grade analysis and visualization. I want you to capture this particular screen. You will work with a small data set of student grades using Pandas. So someone should post this in the chat for me. The task is to analyze, manipulate, and visualize the data without using Matplotlib. So after this, capture this as well. And this is the assignment. So please capture this and save it on your computer if you have not done that. And latest by Wednesday, we will be expecting this work. I'm so happy that we are making progress. Please go back and watch all these videos again. Make sure you are revising, make sure these things you are very familiar with, because these kind of studies, they are building foundation for serious studies. Okay. So the real things you'll be doing, these are just a prerequisite for them. So it is very important that the basics, you really understand them, how to select columns, how to select rows by using log and ilog, how to do filtering, and how to do all these simple things, conditional selections, and all these things. They are very, very important to give you the valuable foundation you need for data related tasks future. So thank you all so much. This is the end of the class. I believe the class has benefited you. Even if you say no, I know that it has, because I can see into the future, and this lesson is for the future. So I know the importance of this lesson. Thank you so much. Let's be consistent, and we will achieve a whole lot here at Rita Africa. Thank you, and I will see you in the next class. I wish you all the best. Bye bye.